Hi everyone. In my previous video, we have discussed about the concept of electrolysis. So, before beginning with the new topic today, please do hit the like button, share the video with your friends, and subscribe my channel. Today, we are going to learn about a topic which is known as electrochemical series. So, as you know that there are various metals, okay, and each metal will have a different tendency or capacity to lose electron. Okay, so whenever a metal, different metals lose electron and they form ion, they are arranged in a series known as electrochemical series, which will show that how easily a metal loses a metal will lose electron to form its corresponding ion. Clear? So what you will see, this is a series given alongside. Here you see the metals which are present at the top. Okay, they will easily lose electrons to form the ions because they will have the low ionization potential. Clear? Now, therefore, potassium or sodium both will lose electron to form K plus to attain the stable electronic configuration. But silver will have difficulty in losing electron to form Ag plus. Okay. Now, the the cations form are very difficult to get discharged at the cathode, which are placed at the top. That means the cations which are placed at the top will not easily get discharged towards its respective electrodes. They will rather be in their cationic form. Similarly, anions also gain electron to form ions, and the anions which are placed at the top of the electrochemical series, they find difficulty in getting discharged at their respective electrode. Clear? So the metals at the top will easily lose electron to form ions, but will find very difficulty in getting discharge at the respective electrodes. Similarly, the metals which are placed at lower end of the series will not ionize easily, but they will be discharged at the cathode more readily than the ions present at the top. Now, suppose in an electrolytical solution, when current is passed, the compounds will dissociate into ions. So you might have different kinds of ions present. Now, which ion will get preferred over the other to get discharged at the cathode or anode will be dependent on certain factors. The first factor is the relative position of the cation or anion in the electrochemical series. The ions, the cations which are placed above in the electrochemical series will not get discharged easily. Suppose you have two cations like copper and H plus. Okay. Now, since copper is placed at the below hydrogen ion, so it will be get discharged at cathode rather than hydrogen ion. Similarly, if you have uh, silver plus and hydrogen plus, okay, so between these two, silver will get discharged at cathode because it is placed below hydrogen in the electrochemical series. Similarly, instead of cations, you have anions. You have sulfate and OH minus. As the position of the OH minus is below the sulfate ion, so it will get discharged at anode. Clear? So the position helps in selective discharge of the ions. Now, there is another factor which will help you to select whether which ion will get selectively discharged at the electrode. The second one is the concentration of the ions. That is, if you have a concentrated NaCl solution and dilute NaCl solution, both will dissociate to form Na plus Cl minus, and since water is present as your aqueous solvent medium, so it will also get dissociated into H plus and OH minus. Now, in case of dilute solution, since the concentration of Na plus is lower than H plus, therefore Na plus will not get discharged at the cathode. Okay, instead H plus will get discharged. Similarly, if you use concentrated or higher concentration of NaCl solution, therefore in that case the concentration of Na plus is more than H plus. So Na plus will get preferred over the H plus to get discharged at cathode. Similarly, in case of anions also, in case of dilute solution, you have Cl minus and OH minus, which will both migrate toward the cathode anode, but OH will get discharged in case of dilute solution, and in case of concentrated solution, the Cl minus will get discharged because of higher concentration. Okay, now we have read about the relative position, the concentration. Now the third topic is the nature of the electrode, the factor. Okay, there are different kinds of electrodes. The first one is the inert electrode, that is electrodes which itself do not take part in the electrolytic reaction. Like we have graphite, platinum, iron. These kinds of electrodes, if made up of iron, graphite, platinum, they do not take part in the electrolytic reaction and they are inert. But we can have an active electrode like copper, nickel, silver, which do take part in electrolytic reaction. Now let us consider an example of copper sulfate solution. This is the ionization where copper sulfate dissociate to form Cu2 plus and sulfate, and hydrogen water will dissociate to form H plus and OH minus. Now if we use active electrode, that is both the electrodes are made up of copper, then at anode, what are the ions which will get discharged, will migrate towards anode, that is sulfate and OH minus. Okay, but Cu2 plus, since copper is an active electrode, it itself will dissociate a loose electron to form copper ions. Now this copper ions will get discharged, although your OH minus and sulfate ions are migrating towards anode, but they will not get discharged. Okay, because of the presence of active electrode. But instead of using anode electrode as copper, if you use platinum, then between OH minus and sulfate ions, OH minus will move towards get discharged at the electrode anode because of its lower position in the electrochemical series. Okay. So the nature of the electrode helps in determining the product form at the anodes or your respective electrodes. Now we will discuss few examples of electrolysis that is there in a syllabus. The first one would be of the molten lead bromide. The second one is of the acidified water using platinum electrode, that is the use of inert electrode. The third one is the use of copper sulfate solution using both the active and the inactive electrode. And the fourth one is the extension of the third one only, the electrolysis of copper sulfate solution using copper electrode. Okay, in the one of the case it is inert and in another case it is active. So let us begin with the first example, that is the electrolysis of molten lead bromide. Instead of using molten, you can use fused lead bromide. Okay, so for this we need an electrolytical cell where your electrolysis will take place, which is made up of silica. Why we are using crucible made of silica? Because it is, first, it is non-reactive, second, it can withstand high temperature, and itself is, as it is non-reactive, it is also non-conductor of electricity. Clear? So what is the electrolyte we need? That is, we need molten PbBr2, that is PbBr2, that is lead bromide. Electrode we have chosen as to be, both electrode needs to be inert. Temperature is set to be around 3800 degrees Celsius, and the current that needs to be passed is 3 ampere. So the first step is the dissociation of lead bromide. Lead bromide will dissociate into its constituents ion, that is lead Pb2 plus and Br2 minus. Now at different electrode, different reaction will take place. At cathode you will see reduction occurring of lead 2 plus getting reduced to lead. Now instead of what are the ions that will migrate towards cathode? Lead 2 plus will always go, but along with it H plus will also go, but since lead position of the lead ions is below hydrogen, so they will get discharged as neutral lead atom. Okay, so what is the product form at cathode? cathode, that is lead metal. You might be asked in your MCQ question what is the product form of which ion is preferentially discharged at cathode. Okay. Now what is the reaction at anode? The bromide ion, which is formed after dissociation, will lose electron, okay, to form Br, and since bromine cannot remain in single atom state, it will combine to form neutral bromine molecule, that is Br2, which is reddish brown in color. So evaporation or evolution of bromine reddish brown color indicates that your bromine gas is formed at anode. Clear? Now, why we have used graphite instead of other inactive electrode? It's just because since your bromine gas has been formed at one of your electrodes, and graphite is non-reactive towards bromine vapors, so we prefer graphite use. Now we will discuss the another example, that is of acidified water. Plain water itself is non electrolyte. Okay, it will not conduct electricity to pass through it. So what we do is that whenever we use distilled water, we will acidify it by using a small amount of acid. In this case, we are using sulfuric acid. We will prefer sulfuric acid over HCl and nitric acid, mainly because of the two reasons. Firstly, your nitric acid and both the acids are volatile, and secondly, they also might break into its constituent ions, and the anions which will be formed might interfere with the electrolytic reaction. So H2SO4 is preferred over the other two acids. Now here we are using an electrolytic cell which is known as Hofmann's voltameter, very important name reaction. Okay, you might be given which voltameter the electrolytic cell used in during the electrolysis of water, and 4 options will be given to you. Okay, and we are using inert electrodes of platinum. So what will happen? The water will dissociate into its ion, that is H plus and OH minus. Sulfuric acid will also dissociate to form H 2H plus and sulfate ions. At cathodes, H plus will migrate towards the cathode and it will accept electrons to form 2H atoms, which are very unstable. They will combine with themselves to form an hydrogen molecule. So at cathode, the product formed is hydrogen gas. Okay. Now anode, you have sulfate and OH minus ion migrating. OH ions will get preference over the sulfate ions, and it will donate 4 electrons because at cathode oxidation occurs. Now these 4 OH neutral atoms are unstable and they will recombine itself to form oxygen. So at anode, oxygen gas is liberated or formed, and at cathode you have hydrogen gas form. Okay, so the product formed during the acidified electrolysis of water is oxygen and cathode at different electrodes. The third example that we are going to discuss is the electrolysis of copper sulfate solution using platinum electrode, that is an inert electrode. So we are using the electrolyte as saturated solution of copper sulfate. Nature of the electrodes are inert. Dissociation of copper sulfate will give you copper ions and sulfate ions, and since water is also present as a solvent, it will also dissociate to form H plus and OH minus. So we have 4 ions present. You might be asked in the question, what are the ions present on when copper sulfate solution is dissociated? Okay. Now a different electrode different reaction will occur at cathode, since you will have Cu2 plus and H plus migrating, but since Cu2 plus is below the position of hydrogen, so copper will get reduced at cathode to form copper atoms, and at anode OH minus will get preference over the sulfate ions and oxygen gas will be liberated. So at cathode you have copper, metal copper forming, and at anode you have O2 gas evolved. Okay, during the course of this electrolytic cycle, you know that copper sulfate is blue in color. So as the reaction proceeds or as the electrolysis happens, the blue color of the copper fades away. It's just because that copper sulfate is composed of copper ions, Cu2 plus. Now as the copper is copper 2 plus ion concentration decreases, therefore the solution becomes colorless as soon as the copper ions diminished completely. Concentration of copper ions diminished completely. Okay, but when you are using an active metal like copper as a electrode, you will see that blue color of the copper sulfate solution does not fade out. You might be asked a very important question in MCQ that you will be given two solutions. In which case will the blue color of the copper sulfate will fade away? In both case, in none of these, in one of them, this will be a 4 option set for you. Okay, so be prepared accordingly. Same electrolyte we are going to use. Instead of platinum we will be using copper as the anode. That is an active electrode, that means it will take part in the reaction, and the ions present will be same as the earlier case only. There will be no change in the reaction at the cathode. Okay, it will be same as that were used when you are using copper electrode or in case of platinum. Okay, the change will occur only at the reaction at cathode, because in cathode the copper electrode will start itself losing electrons to form copper 2 plus ions. Now copper 2 plus ion is responsible for the coloration of blue, okay, for copper sulfate. Now we, as you see, in case at cathode copper 2 plus is getting discharged to form copper atoms, but at anode you are again forming copper 2 plus ions. So therefore the concentration of copper 2 plus ion does not decrease at all. This is the reason why your blue color does not fade during the course of the reaction. Clear? And what will be the product from an anode? Since the copper itself starts to degrade, therefore the product at anode will be nil. No product will be formed at cathode. Sorry, not at cathode, anode. Clear? Now you need to acidify copper sulfate solution to enhance its activity. Okay, and prevent its hydrolysis. Copper sulfate is very soluble soil and it might undergo hydrolysis. So to prevent this, we need to add little amount of sulfuric acid. Now the application of electrolysis. Till now we have discussed about the concept, the electrolytes, the electrolytic cells, various examples, what are the factors which might affect electrolysis, or which ions will get discharged at the respective electrodes. Now we will come to the applicative portion of electrolysis. Why do we use electrolysis in a daily life? Firstly, we use electrolysis for electroplating the metals. We use electrolysis for electrorefining of metals, and thirdly for extraction of metals. The first application is the electroplating. So what is electroplating? It is a process in which a thin film of a metal like gold, copper is electroplated or decomposed or deposited on a metal surface of another article with the help of electricity. The kind of metal we will use for electroplating is of like gold, silver and nickel. Why do we need to do electroplating? Firstly, for the decorative purposes. Like brass objects are frequently plated with silver to give it a shiny appearance and enhance the beauty of the silver article. Similarly, to protect the material or article from getting rusted or getting corroded. So, iron tools or instruments are often electroplated with nickel or chromium to prevent them from rusting. Clear? Now we will go into detail explanation or how this electroplating process works. So, first example we will do electroplating using silver. Now for that we need an electrolyte, that is we will use sodium argentocyanide or potassium argentocyanide as my electrolyte. We directly cannot use a simpler silver salt, because what will happen is that the simpler salt will itself take part in the reaction and will and the decomposition of silver will be very fast, so there would be no smooth and uniformity when the electroplating process occurs. So we use a complex salt like sodium argentocyanide or potassium argentocyanide to enhance the efficacy of electroplating, that is a smooth and uniform decomposition of the metal silver on the article takes place. Okay. So we have used, this is a chemical formula for sodium argentocyanide, which is a complex salt. Okay. Now what we will do is, the metal to be electroplated, that is silver, is placed at cathode, and the article to be on which the electroplating will occur is placed at anode. Okay. Slow current will be used to enhance the uniformity and smoothness. Now we will do the dissociation of the electrolyte. That sodium argentocyanide will dissociate to form sodium ions, silver ions and cyanide ions. Along with the water will also get dissociated to form H plus and OH minus. Now since at cathode your silver ions will get reduced to form silver, and this silver will be attracted to the article present at anode. Okay. Sorry, the article to be electroplated is placed at cathode, and the metal to be electroplated is placed at anode. So the silver electrode will lose to form silver ions, and it will get attracted towards the metal. Therefore the atoms of sodium lose electron and pass into solution as Ag plus due to the active nature of the electrode. Okay. Now since anode will take part in reaction, so Ag plus is formed. This Ag plus will get plated over the your brass spoon, jug and etc. the article. Now we will do electroplating with the help of nickel. Similarly, just as we have done with the help of silver, here we will use nickel sulfate solution as an electrolyte. And now the nickel sulfate solution will dissociate to form nickel ions, sulfate ions, OH minus ions and H plus ions are the ions formed on dissociation upon water. Okay, since your nickel is an active electrode, it will take part in reaction and your nickel ions will get decomposed or deposited over the article present at cathode. Okay, so at anode you will see a reduction of nickel 2 plus ions to form nickel, and at anode you will see nickel ions getting loses electron to form nickel 2 plus ion. Although you will see that sulfate and OH minus migrate to the anode, but neither of them are discharged due to the active nature of the electrode. Hence, nickel anode loses electron to give Na2 plus nickel ions in the solution, which will be migrated towards the cathode and deposited as nickel metal. Okay. Now the second application of electrolysis is the electrorefining. Refining means to make anything pure, and electro means the use of electricity. So how will you define electrorefining? It is a process by which the metal containing impurities are purified electrolytically with the help of an electrolytic solution to give a pure metal. Now as an electrolyte we will use aqueous. Example we will be using as aqueous copper sulphate solution. Nature of the electrodes, we will at anode we will use impure block of copper. Okay, and at cathode we will use pure sheet of copper, that is we are using an active electrode. So what is the electrolytic dissociation of copper sulfate, it will break down into copper ions and sulfate ions. Also an aqueous solution is present, so water will also break down into H plus and OH minus. Now at cathode, since copper 2 plus ions will get reduced to form copper metal. Okay. Now at anode, since we are using an active electrode, so the copper will lose electron to form copper ions, and they are preferred over the sulfate and OH minus ions discharging at the anode. Okay. So what will happen is that since copper is getting used up, the impurity present in anode will settle down. The pure copper metal will dissolve out from the copper anode, and the Cu2 plus ion formed in the solution at anode will be deposited at cathode, that is on the pure sheet we have used. Okay. The impurity present in the copper anode will settle down as mud, which will contains impurities. Metals which are generally electrorefined are of high electropositive nature. So the metals which will be electrorefined can be copper, mercury, silver, zinc or lead. These few metals are electrorefined using electrolysis. The last application of electrolysis is the extraction of metals using electricity. That is, since the metals which are placed at higher electrochemical series are generally extracted by electrolysis because their oxides and other ores are quite stable to heat and thermal condition. So we prefer electrolysis for their extraction. So the metals to be extracted which is there in your syllabus is potassium, sodium, calcium, aluminum. All are placed at the top of the electrochemical series, and we will be using inert electrodes. Okay, so for potassium we are using the electrolyzed potassium bromide, which will break down to form your K plus and Br minus. At cathode, reduction of potassium ion will take place to form potassium atoms, and at anode the bromide ions which are formed will lose electron to form bromine atoms. Since bromine atoms are quite unstable, so two atoms of bromine will combine to form bromine molecule, and we will see a reddish vapor getting evaporated, which will confirm us the presence of bromine gas as your product. Similarly, for sodium, we will be using NaCl as a electrolyte, which will decompose to give Na plus and Cl minus. All the metals that are to be extracted are getting formed at cathode. Okay, they will get reduced from its ion to form respective metals. For calcium, we will be using calcium chloride as electrolyte, and the reduction at cathode is calcium 2 plus will accept 2 electrons to balance out the charge to form calcium atom. For aluminum, we will be using aluminum oxide as the electrolyte, which will dissociate to form your aluminum ions and oxide ions, and these aluminum ions will get discharged at cathode by forming neutral aluminum atoms. Okay, this was all about electrolysis, which is there in your syllabus. Thank you.